System management, storage concepts. Understanding storage concepts in Linux is essential for managing files, ensuring data redundancy, and optimizing system performance. In this section, we'll cover file storage, block storage, object storage, as well as important partitioning schemes and RAID levels. You'll also learn about Fuse, Filesystem in Userspace, and the differences between MBR and GPT partition tables. File storage is the most common and traditional form of data storage. In file storage systems, data is stored as files in directories, which are organized into a hierarchical structure. Files are typically stored on a hard drive, SSD, or network-attached storage, NAS, and accessed via a file system such as EXT4, XFS, or NTFS. Common file systems. EXT4, the default file system for many Linux distributions. It provides journaling, ensuring data integrity. XFS, a high-performance file system designed for large-scale storage systems. Use case. File storage is ideal for everyday tasks such as storing documents, media files, and application data. Example of file storage interaction. Viewing files in a directory. ls/path/to/directory. Block storage is a lower-level type of storage, where data is divided into fixed-sized blocks. These blocks are then written directly to storage devices like hard drives or SSDs. Unlike file storage, which is more user-friendly and higher-level, block storage offers greater performance and flexibility. Examples of block storage devices: hard disk drives, HDD, and solid-state drives, SSD. Network block storage like ISESI and Fiber Channel. Interacting with block storage. To view block devices, LSBLK. Viewing partitions on a block device, fdisk l/dev/sd. Why block storage? Block storage allows direct access to specific blocks, making it highly efficient for databases and high-performance applications. Object storage is a more modern form of storage, where data is stored as objects in a flat, non-hierarchical structure. Each object consists of the data itself, metadata, and a unique identifier. Object storage is highly scalable and commonly used in cloud environments. Advantages of object storage. Scalability. Object storage can handle vast amounts of unstructured data, making it suitable for cloud storage and web-scale applications. Metadata. Each object includes metadata, which can be used to describe and manage the object. Examples of object storage. Amazon S3, Simple Storage Service. OpenStack Swift. Object storage is ideal for large-scale, unstructured data storage like backups, media files, and cloud-based applications. Partitions divide physical storage into isolated sections, each of which can have its own file system. There are two main partitioning schemes in Linux: Master Boot Record, MBR, and GUID Partition Table, GPT. Master Boot Record is an older partitioning scheme that has been in use since the early days of computing. Characteristics: supports a maximum disk size of 2 terabytes. Allows for up to 4 primary partitions. If more partitions are needed, one of the primary partitions can be converted into an extended partition, which can contain multiple logical partitions. Limited scalability, 2 terabytes max size. Fewer partitions, only 4 primary partitions. To view MBR partitions on a disk. GUID Partition Table, GPT, is the more modern partitioning scheme that replaces MBR and is part of the UEFI standard. Characteristics: supports disks larger than 2 terabytes. Can have up to 128 partitions without needing an extended partition. Contains redundancy by storing multiple copies of the partition table. Advantages: greater scalability, supports very large disks. More flexible and robust partitioning structure. To view GPT partitions on a disk, sudo disk/dev/sd. Fuse allows the creation of file systems in Userspace, meaning it runs outside the kernel. This is useful because it allows developers to create and implement file systems without modifying the kernel. Fuse is widely used for network file systems, cloud storage integration, and encryption. Fuse is ideal when developing custom file systems or integrating non-traditional storage mechanisms, such as cloud storage services or encrypted file systems. Examples of Fuse file systems. SSHFS, a Fuse-based file system that allows you to mount remote directories over SSH. XFS, a Fuse-based encrypted file system. To mount a remote directory over SSH using Fuse, SSHFS user at remote /path/ to /remote /dir /local /mount /point. RAID is a technology that combines multiple physical disks into a single logical unit to provide redundancy, improve performance, or both. There are different levels of RAID, each offering different trade-offs between performance, data protection, and storage efficiency. RAID 0, striping. RAID 0 splits data evenly across 2 or more disks, striping, increasing performance because data can be read from or written to multiple disks at once. Advantages: significantly improves performance. Disadvantages: no redundancy. If one disk fails, all data is lost. Usage: suitable for performance-critical systems. Ideal for temporary storage or non-essential applications. RAID 1 mirroring. RAID 1 duplicates data across 2 or more disks, mirroring. This provides redundancy because if one disk fails, the other contains an exact copy of the data. Advantages: high redundancy. If a disk fails, the data is still available on the mirrored disk. Disadvantages: no performance gain and storage efficiency is halved since data is duplicated. Ideal for systems requiring data redundancy and commonly used in database servers and backup systems. Also, ideal for operating system OS installation. RAID 5, striping with parity, combines striping with parity. Data is striped across 3 or more disks, and parity information is distributed across the disks. If a single disk fails, the data can be reconstructed from the parity information. Advantages: provides both performance improvements and redundancy. Disadvantages: RAID 5 requires at least 3 disks and rebuild times after a disk failure can be long. RAID 5 is commonly used in systems that require both performance and redundancy, such as in web servers and file storage systems. In conclusion, storage management in Linux involves understanding different types of storage like file, block, and object storage, as well as the different partitioning schemes, MBR versus GPT, and RAID levels. By mastering these concepts, you'll be equipped to manage data storage efficiently, ensuring both performance and data redundancy.